What is geoengineering? Geoengineering refers to deliberate interventions in the Earth's climate systems to alter temperatures or precipitation systems. Solar geoengineering does this by modifying how much sunlight reaches and is absorbed by the Earth. With the rising global temperatures, solar geoengineering has been proposed as a solution to cool the planet. Cloud seeding is the process of injecting particles into the atmosphere to increase cloud coverage. This would be a human-made effort to manipulate the Earth's natural systems in order to reduce the amount of energy the Earth takes up from the sun. With the rising global temperature, solar geoengineering has been proposed as a solution to cool the planet. But how do we know if this will work? Well, in the 1990s, through a volcanic eruption in the Philippines. This eruption threw millions of tons of volcanic ash into the atmosphere, which created a reflective aerosol cloud around the Earth, reducing the amount of sunlight that reached the planet's surface by roughly 10% for the next 2 years. As a result, the average global temperature dropped by 0.9 degrees Fahrenheit. That might not sound like a lot, but it resulted in a 5% decrease in a worldwide soy, rice, and wheat crop yield. This eruption created the perfect natural experiment, offering scientists a model for how deliberate efforts could counter global warming in the future.
There's been research on solar geoengineering since at least the 70s, when the National Academy of Sciences released its first mention of it in its 1977 Energy and Climate Report. Research has been steadily expanding into biology, physics, chemistry, and environmental science, creating a transdisciplinary scene. One of the first places to operate under this approach is Arizona State University's School of Sustainability, which combines these research areas. Other universities have replicated this model, such as Harvard's Solar Geoengineering Research Project.
Let's jump back into the two approaches, removing energy-absorbing materials or adding energy-reflecting objects, and talk about cloud seeding. Most people have probably heard of carbon capture technologies, which work by taking CO2 out of the atmosphere. Cloud seeding does the opposite of this through projecting chemicals called seeding agents into the atmosphere. This is done through ground-based rocket launchers and sky-based machines like airplanes. The most common seeding agents used in cloud seeding are silver iodide, with some uncommon ones being lead iodide and liquid CO2. The list of chemicals goes on. Cloud seeding is a combination of many technologies, such as rainfall enhancement, snowfall enhancement, hail reduction, and decreasing fog cover. Two unique technologies that have a potential to reduce global heat are cirrus cloud thinning, which makes heat leave our planet easier, and marine cloud brightening, which makes heat be reflected back into space.
The second approach is directly adding materials to the stratosphere that reflect the sun's energy. This is like replicating that natural cooling effect from volcanoes by reflecting the sun's rays. A recent launch by the startup Make Sunsets included a weather balloon filled with sulfur dioxide set to release into the stratosphere. What cloud seeding does is different. Cloud seeding uses particles or heat to create clouds or induce rain. Another proposal to make the Earth more reflective is to skip the atmosphere altogether and create large umbrella-like structures in space that shield the Earth from some of the incoming solar radiation. All of these approaches, from carbon capture to the space umbrella, are at the moment extremely small in scale and highly controversial. More on that in a moment.
So if we can change the climate and temperature, what would be the result? Both approaches pose some negative risks. Actions that result in lowering the temperature would affect the hydrological cycle, which could reduce global precipitation and increase chances of droughts. This could heavily impact agriculture and freshwater supplies. There are also ethical concerns to an application that could benefit some areas but hurt others. For example, studies of volcanic eruptions such as Mount Pinatubo show that weather cycles disproportionately change near the equator. So countries that are near the equator face larger climate impacts. In addition, determining who would be in charge of regulating the Earth's temperature may cause potential conflicts between opposing nations. There are also major concerns around religion. Some people say we shouldn't be playing God with the environment, and have moral concerns with the intentional manipulation of the planet's environment to counteract human-caused climate change.
The future of solar geoengineering is not yet certain. Today, the use cases are limited and exist in a legal gray zone without established international law regulating it, outside of the Environmental Modification Convention. This has resulted in an ambiguity leading state actors, nonprofit organizations, and academics to debate over the utility of geoengineering as a tool for good or a weapon of destruction. Many places have moved past this debate, such as Saudi Arabia, China, and some states in the United States that have official cloud seeding programs.
But if this technology has the potential to solve the issue of global warming, why hasn't it happened yet? That answer depends on which expert you ask. Many point to the cost, others say it's unethical because of the unintended consequences, and others still are concerned about the geopolitical consequences and the potential for climate wars. Taken together, solar geoengineering represents a technology that we have enough technical knowledge to create, but not enough consensus to implement into global society.
A solution that many people see as radical now will be acceptable in the future.